Hello everyone, so I am the batch and now I'm starting the group presentation for our group number 44 and the teammates are Ankit Agarwal and Rahul and uh, the roll numbers are written right here. So starting from the problem statement, uh, our system addresses the critical issue of uh, dead stock and audit failures caused by manual records that fail to track expiry dates at batch level. So what is the solution? We provide a centralized relational database management system that tracks every medicine unit from production to the final state. Now, what are the target users? The platform integrates manufacturers, distributors, retail pharmacies into a single cohesive supply chain. Uh, what are the key features? Uh, Coming to the key features, we implemented FEFO, first expiry, first out, and automated database blocks to strictly prevent the scale of expired monies also. Now, coming to the justification for the need of database, uh, the relational database is required to maintain data integrity, enforce normalization, and provide the complex traceability uh, needed for drug records. Thank you. Now for the task two, let's look at our conceptual model. At the center of our ER diagram is the batches entry. We designed it this way because the entire pharmaceuticals chain uh, relies on batch level integrity rather than just the total stock. You can see the manufacturers and medicines are the top level entities that feed into these batches. We have also included entities for stock movement, expiry alerts, returns to ensure a complete audit trail for from the factory to the pharmacy. Now coming to the constraint table, mm, we have designed strict cardinality to prevent data errors. For example, in the manufacturers and defines type relation, the batch side has one constraint. Uh, that This means a batch cannot exist in our database unless it is tied to a specific uh, manufacturer and a medicine. Similarly, the sold as and triggers relationship ensures that uh, every sale and every expiry alert is mapped directly to the unique batch ID. This level of detail is what allows us to automate safety checks. Now coming to the relational model, relational scheme. Uh, this is our relational scheme. I hope this is good. Uh, so when we converted this ER diagram into relational scheme, we focused on normalization. We separated the distributor inventory and pharmacy inventory tables. This allows us to track quantity available uh, and specific shelf location independently across different stages of supply chain. We use primary keys like batch ID uh, and inventory ID to ensure every row is unique, while foreign keys link these table to preferential integrity. By bridging this conceptual ER model with a strictly constrained relational scheme, we have built a system that doesn't store uh, data only; it enforces the life-saving rules of the pharmacy industry.
Hello everyone, I am Rahul. I will be discussing about the schema design and the data that we have inserted in our task 3. Let me begin with the tables. So these are the 11 tables that we have made for our database system. These are tables that handles and manage everything that we required for our app. Let me use the describe command to show the constraint and other things for these tables. I have already pasted this command so that we can save the time. So these are the description of each table. We can see the type of the column in each table. For example, in batches, batch ID is integer type, and this is the primary key of this table and has an auto increment. This means that the new row that will be going to enter in this table will be assigned a unique ID that is just the increment of the last inserted row. we have we have all these tables and their descriptions as shown here. For example, the pharmacy inventory, we have inventory IDs, integer types, shelf location, and the varchar of 255 characters, and the last updated as the timestamp type. Now let me show the indexing we have used. Again, I'm pasting the commands directly. So these are the indexing that we have used in our tables. For example, in batches, we have batch ID, medicine ID, and manufacturer ID as our indexing. And all this indexing is done using the B trees. Similarly, in sales table, we have used B trees, and in stock movements, we have B trees. In stock movements, we have movement ID and the batch ID as our indexing. Let me show you the content of some table. So let's start from batches. So this is the content we have entered in our database in the batches table. We have medicine ID as the auto increment, that is 1, then 2, then 3. We have entered the type of medicines, paracetamol, amoxicillin, and the cetrazine. So this is the database and the schema design that we have made in our database. Now in task 4, these are our tables that we have already shown in our task 3. In this task, I am going to demonstrate how this actually powers our database, means how this tables actually powers our application. I am going to run some commands that are from basic level to the advanced SQL level. I have already saved this command, so I am going to directly paste them into the terminal. This is our first command, that is a basic command of select using the where clause. It basically selects the name category therapeutic class from the medicine table, and the condition it applies that the required prescription must be false. Let me show you the medicine table. So this is our medicine table, and it has extracted the name, the category, and the therapeutic class from this table where the prescription is not required, means the prescription is not required in paracetamol and cetrazine, and it has selected and printed this command, that data in the terminal. Let us move to the next command. This is a slightly intermediate level command that uses join of two tables. We have joined medicine and the batches table. According to that, the medicine ID should be equal to the batch ID, that is the natural line. And we have selected the name, batch number, expiry date, and the quantity produced. Let me show you the batches table. We have already shown the medicine table above. So let's start from batches. This is our batches table, and it has joined these two tables and given this output according to the conditions that we have applied here, and ordered them by the ascending order of their expiry dates. Let's move to the third command, that is more advanced than the previous one. This first join the medicines and the batches on the basis of, again, their ID should be equal, and it applies that their expiry date should be less within the 90 days of the current date, and their status must be active. They have selected the batch number, the medicine name, the batch expiry date, and one more column, that is the date difference, that is the time left in the expiring of the medicine, and put this date difference under the days left column. Now moving to the fourth command. So this is our fourth command. This uses join operation, group by clause, and the order by clause, and the normal select clause that you have used till now. So it basically selects the pharmacy name and their total transactions and sum them, and uses this formula to calculate their revenue, and it puts their summation of the revenue under the total revenue. It is using an aggregate function of the sum and count. This select all these things from the sales table and joining the pharmacies on the pharmacy name, where the pharmacy ID is equal to the pharmacy ID of the sales, and group them by the pharmacy name, and it rank the revenue according to the descending order, means the highest revenue will come at the top. As we can see here, the 150 is at the top, then 64, then the 50. It means this is in the descending order. Let me show you the sales table. This is the sales table that we have used, and we have pharmacies table. Pharmacies. This is the pharmacy table. This command has joined these two tables and given us this desired output according to the conditions that we have applied. It has performed the join, it has performed the group by, and ordered them according to the descending order of the total revenue.
Hi guys, I am Ankit and I'm going to explain the task 5 of our project. So this is our UI. In this we have implemented 3 interfaces, one for the manufacturers, that are the pharmaceutical companies, the next interface is the distributors, and the third interface is the pharmaceutical company itself. So I'm going to log in the distributor, first manufacturer. Yeah, so as you can see we are logged in, and this is the interface. So this is the batches that are prepared by this manufacturer. Here we can introduce new medicines, and for new medicines we can create several batches, and that batches can be launched here. And here you can see all the batches. Some of them are expired. These are shown by the black color. Yellow is for the batches which are about to be expired, so they have more than 1 month of date, and these are the green ones which have more than 6 months of date left. Now what we do is go out and log into the distributor. This is the interface in which it shows you can buy the medicine, all the available medicines from the manufacturer. You can put your warehouse location and confirm the purchase. So in this we have implemented a trigger that when you are buying from the manufacturer, it checks all the conditions like expiry dates. It needs to be more than 6 months before they sell, and plus it checks all other conditions like batch ID, manufacturer price, total quantity. And when you confirm this purchase, it will only accept it if all the conditions are met properly. Here you can see this is the inventory, and it is the total inventory value shown here. You can check the purchase history from this part. It will show all the purchases. Now this is the important part. It will show all the medicines which are about to expire. So all the medicines which are in yellow or red color label, that is they are about to expire in a week or they are about to expire in a month. Now here we have implemented two other triggers. Now here to sell to the pharmacy, we need to check two things before selling. All the prerequisites are made. That is, you can only sell the green color labeled medicines to the pharmacy, and secondly, you can only sell whenever the sale is done, it will directly change the stocks from your side, so that it will deduct the stock from your side and it will add the stock into the pharmacy's side. So here two triggers are implemented in that way. Now I'm going to show the pharmacy side, pharmacy interface. Yeah. Now here also we have implemented one trigger, that is how to sell. If you are selling a batch, selling a medicine, you can only sell if these are not expired. So here the trigger is that if the medicines are expired, you cannot sell them to any of the customers. Yeah, so that is it. We have implemented 5 triggers in this, and this is for the task 5. Thank you. Hi guys, this is task 6. In this we have implemented 9 transactions, 3 transactions per member. In this this is the test one. So in this test we have implemented atomicity, or we have tested atomicity. In this, if two customers are trying to buy the same medicine, then it puts a lock in them. So one customer buys it, then only other customer can buy the same medicine, because there is a chance that there is only one batch of medicine is available. So if two customers try to buy it, then it would lead to concurrency situation. Now this is task 2, test 2, sorry. In this we have implemented a full simulation, in that when a manufacturer sells to the distributor, that is the distributor buys from manufacturer, all 3 tables are updated simultaneously. If even one of the operations are not successful, then the whole operation gets rolled back. So it checks for atomicity and consistency. In test 3 we check the isolation. So that is, if we are modifying one of the data and it does not get committed, so another transaction will get the original value itself. So here we check whether one transaction is dependent on other, and if yes, then until and unless it is committed, the other transaction will use the original value itself. Here we implemented the foreign key constraint to just check whether there are no orphan records, and to delete all the medicines. This is mainly to check if deleting the medicines, delete all the medicines and its batches associated with it in all the tables simultaneously. Now this is the 5th test. This is for registering the batch. It checks for atomicity and consistency, because manufacturer should not be able to register a batch whose medicine is not available or not created by himself. So a batch will be only created if the medicine is available and it has a proper expiry date of more than a year. We have implemented some conflicting transactions as well. Like in test 6, we have given 5 threads to update the same inventory. Here our project avoids this by giving lock to only one thread, and others are still waiting. So hence all the this is done because if all the threads are simultaneously allowed to update the inventory, then this would lead to inconsistency, as thread 1 might read like a inventory of 100 and it calculates to 99, but thread 2 also sees 100 and it calculates to 99. Instead it should have been 98. Yes. Now test 7, it was for adding for buying insufficient stock. That is, you cannot sell more than what you already have in your stock state. This is to avoid selling the expired batches. It will make sure that you cannot sell expired batches to any of the other customers. So manufacturer can't sell it to the distributor, and distributor can't sell it to the pharmacy if those batches are expired. Implement the test 9, which is the deadlock scenario. In this, what we did is we took 2 threads, that is thread A and thread B. Thread A wants to update inventory 1 and thread B wants to update inventory 2. But now thread A is dependent on inventory 2, which is locked by thread B, and thread B is dependent on inventory 1, which is locked by thread A. So both are dependent on something which is locked by each other. That leads to a deadlock scenario. Hence we check this and it passed our test. Yeah, so that is it. We implemented 9 transactions and it all passed.